Hi students, today we are going to discuss about a case study on closed loop control system and its applications. Okay, first of all, what is closed loop system? Sometimes to attain a consistency and stability of a system and to produce the desired output of a control systems, we use feedback loop. A feedback is nothing but a part of output signal. This concept is most frequent and important in control systems to achieve the stability of the output. Okay, based on the feedback connection, the control systems are classified into two types. They are open loop control system and closed loop control system. A control system with feedback it is called closed loop control system. Without feedback is open loop control systems. Okay, in this, first of all, we discussed about closed loop feedback system, that is closed loop control system. A control system with a feedback loop is called a closed loop control system. In other words, the control system which uses its feedback signal to generate output is called closed loop control system. In these control systems, the input is controlled by the feedback signal from input. So that it can correct the errors occurred. Closed loop control systems are two-way signal flow systems because we have input signal and also we have feedback signal. Feedback means some part of output is taken and connected to the input of the system to maintain the stability of the control system. By providing feedback loop, we can convert any open loop system into closed loop system. The feedback loop provides the automatic correction of the input signal based on the output requirement. Okay. By comparing the generated output with the actual condition, the closed loop system maintains and achieves the desired output. We know that. If the produced output is deviated from the desired output, that is actual output, the closed loop control system generates an error signal and the error signal is fed into the input of the signal. So, by adding the error signal to the input, the generated output of the next loop will be created. So, these are called as automatic control systems. Closed loop systems are less prone to external disturbances. Okay, and we have control system examples, and in this closed loop control system we have input, we have a controller, we have a plant, and we have a feedback from output to input, that is error signal. Okay, and we have finally controlled output. As these systems contain feedback loop, the closed loop control systems are also called feedback control systems. Okay, by giving the feedback to the input signal, we can accurately control the output of the control system. A closed loop control system can have more than one feedback loop. Here we have an example for open loop control systems. For example, we have a washing machine, we have a traffic signals. Note that any control systems that operates on a time basis or open loop. Time basis, it can maintain the time basis, it can maintain the time slots. It is open loop control systems. Okay, in open loop we have simply we have input and output and one way connection between input and output. So we have either on or off. Okay, for example, we have for tap we have water on or water off. That's it. We have examples from switch and water tap, either on or off. It has only two states. There is no feedback signal in open loop system. Okay, in closed loop system we have a control system with an automatic feedback loop, a direct connection between output and input. Okay, input we have set light, medium or dark. In this we have, and feedback we have setting a reached toast pops up. We have medium, light and dark, and the output is toast is way you want it. Okay, a closed loop system with the automatic feedback loop, it provides effective output at the end. Okay, and here we have an example. Okay, we use closed loop control systems in many applications in our day-to-day life. Some of the systems designed based on the concept of open loop control systems are given below. For example, automatic electric iron, depending on the temperature of the iron heating elements, were controlled automatically. And we have a servo voltage stabilizer. A stabilization in voltage is achieved by the feeding of the output voltage back to the system. And we have water level controller. Here the water level in the reservoirs desire the input water into it. And we have an air conditioner. Air conditioner automatically adjusts its temperature depending on its room temperature. And in motor speed, the regulator using a tachometer or a current sensor, the sensor sends the speed and sends feedback to the system to regulate its speed. Okay, and we have a practical example of feedback system. Okay, and thus we have in market we see some automatic cloth dryers. Does anybody know that they are on example of closed loop control system? In automatic control system or closed loop feedback system, we use a transducer at input side of the system to continuously monitor the temperature of the clothes inside the dryer. Okay, and thus we have a desired time for input, and we have actual dryness at the output, and also we have a feedback signal from the actual dryness to desired time, and also we have electrical energy, and it is fed into the timer, and we have a heating element, and we have heat from the heating elements, and it is fed into the clothes. Finally we got actual dryness. Okay, here how control system plays an important role. Here the temperature sensor will monitor the state of the clothes, whether they are dry or wet, and compare it with the submitted input reference. If the cloth state and the desired output are not matched, not similar, then the system generates an error signal and sends it back to the input. Okay, here the amplifier, it produces the amplified output of the signal to the controller so that it can adjust the heating elements to the desired output level. So if the clothes are about to dry, then the controller regulates and lowers the temperature or stops the heating process of the heating elements to an extent that it doesn't burn the cloth in the machine. Okay, here, the closed loop system is capable of handling the external noise disturbance which cause to reduce the system efficiency by means of the feedback signal. For example, if we open the dryer, some amount of temperature is lost and the inner temperature of the system will decrease. Then the feedback sensor will calculate the temperature of the clothes, and then it sends an error signal to the controller so that the controller sets the required temperature in the system. This will be the process of handling an error in the occurrence of cloth dryer. The error signal means the difference between actual output and the produced output, and this error signal is provided as an input to the controller to regulate the system output. If the error signal is 0, then only the desired input is equal to the produced output. That's it. So, closed loop control system mainly used in real-time applications, and it is used to produce effective output to the systems. Thank you.